let's take a look at the inverse function theorem. So what does this inverse function theorem say? Suppose that we have this differentiable function f, and it is differentiable on some interval I, and the derivative is not equal to 0 for every single choice of x in that interval. If we know those things, then we can say three different things about this function. So one, we can say that function has to be injective. Two, we can say that function has to be, the inverse function has to be differentiable on f of I, right? On the image of that interval, the output of that. And that the derivative of the inverse at y is 1 over the derivative of the function at x, where y is equal to f of x. All right, so let's go through, let's take some time to prove this. All right, so proof. Since f prime of x is not equal to 0 for all x in I, it follows from Theorem 6.2.9 that either f prime of x is strictly greater than 0, or the derivative is strictly less than 0 for all x and I. Thus, f is either strictly increasing or it is strictly decreasing. In either case, we have f is injective. Yeah. So that's, we have the injectiveness. We might also note, since f is continuous, f of I is an interval. And f inverse is continuous on f of I. That's from a previous result. So to see that f inverse is differentiable, we can let y be an element in that, in f of I, and let the sequence y sub n be a sequence in f of I that converges to to y with y sub n not equal to y for all n. We can let x be equal to f inverse of y, and x sub n be equal to f inverse of y sub n for all n. Since f inverse is continuous, we can say that the sequence x sub n converges to x also x sub n is not equal to x for any x, for any n, since f is injective. Since f has a non-zero derivative at x, since f has this non-zero derivative at x, then we know that this limit of f of x sub n minus f of x over x sub n minus x as n goes to infinity. This should be equal to the derivative at x, and that should be non-zero. Thus, the limit of f inverse of y sub n minus f inverse of y over y sub n minus y, that should be equal to this, which is simply 1 over f prime of x. And so this part here we do end up with, it is differentiable, and not only do we get the differentiable part, we actually get what it is that derivative is equal to. And that is that. All right. In the next video, we are going to take a look at L'Hopital's rule. We will talk to you then.